All right, in this video, we're going to derive the quadratic formula using vertex form. So what I have right here is I have two ways to write out quadratic functions. So this is standard form, y equals ax squared plus bx plus c. And then this is vertex form, y equals a times the quantity x minus h squared plus k, where the point h comma k is the vertex. So what I'm going to do here is I'm going to set both of these equal to 0. And my goal is to basically solve for h and k in terms of a, b, and c, plug those in, and then solve this equation in vertex form for the 0. So once again, these are the quadratic functions y with the y, but I'm going to set them equal to 0 to solve any quadratic equation. So I'm going to start by doing 0 equals a times x minus h quantity squared plus k. By the way, the a in vertex form and the a in standard form are the exact same. You'll see why in a little bit. So anyway, what I'm going to do right now is just try to write this in standard form. So I'm going to square out my x minus h. So that's going to become a times x squared minus 2hx and then plus h squared. If you didn't know how to, if you didn't know the special case of squaring the binomial, you could just FOIL it out. Anyway, this is all plus k, and then all equal to 0 on the other side. Next, I'm going to distribute this a to all three of these terms. So I'm going to get ax squared minus 2ahx plus a h squared plus k. And that is all equal to 0. So now technically I have a standard form equation. I have something times my x squared term, and then I have something times my x term, and then I have some constant term, which in this case it's made up of multiple constant terms. So anyway, I'm going to write the standard form of a quadratic equation below this. 0 equals ax squared plus bx plus c. So if you look at it, the a's are the exact same. This a right here is equal to this a. Okay, so I know I've just kind of proven to myself that a is the same in both vertex and standard. And that's why we have that a be the same in both of those forms. So the next coefficient I want to look at is this plus b. So I want to see in our new vertex form what number, or in this case number and parameters, are being multiplied by the x term. And the only thing that's being multiplied by the x term is this negative 2ah. So this negative 2ah in this expanded vertex form is the exact same thing as positive b. So I'm going to rewrite that. So I get b equals negative 2ah. All right, and then the last thing is the constant. In standard form, it's just plus c. So I know positive c, and I'm including the sign here just to show you that it's positive c. And then this ah squared plus k, there's no x term. So this entire sum, this is the constant term when we expand vertex form. So this ah squared plus k is going to be equal to c. So I'm going to write that here. So c equals ah squared plus k. And remember the goal here. The goal is to find the values of h and k in terms of a, b, and c. So we know that the a equals a, so we don't have to worry about that. And then right here for this equation, I'm going to solve for h in terms of b and a right here. So h, I'll rewrite the equation actually. b equals negative 2ah. I'm just going to divide by negative 2a on both sides. So I get negative b over 2a equals h. So this is my h value in terms of a, b, and c. There's no c here, but in terms of a and b at least. And now I'm going to use substitution. I'm going to substitute this h value in for this h value to find what k is in terms of a, b, and c. So I'll plug this in for my h squared. So I get c equals a times, and then negative b over 2a quantity squared plus k. All right, so when I square this out, the negative is going to turn to a positive. This is going to be b squared over 4a squared, and then all times a still, plus k. And that's equal to c. Now I'm just gonna, what I can do is I can cancel out this a with one of the a's here. So basically this a will cancel, and then the squared will just turn into the first power, so I don't need to write that. So that turns into c equals b squared over 4a plus k. And then the last thing I need to do is just get rid of this term on the k side, so we have k isolated. So I'll subtract it, subtract b squared over 4a on both sides. So now I get k equals c minus b squared over 4a. So that's my k value in terms of a, b, and c. And my h value right here is negative b over 2a. I'm just going to rewrite that down here. So h equals negative b over 2a. So now what I'm going to do is I'm going to plug these things in to my vertex form and then solve by simplifying the quantity x minus h squared part, taking the square root of both sides, and then simplifying from there. So remember, for vertex form, it's when we want our y value to be 0, it's 0 in this case equals a times x minus h squared plus k. So now I'm just going to plug these things in. So this is really 0 equals a times x, and then I have double negative here, minus a negative, so plus b over 2a squared plus, and then k, which is the whole value, is c minus b squared over 4a. All right, so now to solve this, I just want to isolate this binomial that's being squared right here, the thing in the parentheses, so then I can square root it. So what I'm going to do is subtract this k term on both sides. And now you could have basically done it in terms of k and then plugged in after. It doesn't really matter. So I'm going to subtract c and add b squared over 4a on both sides. So now I get negative c plus b squared over 4a equals a times the quantity x plus b over 2a squared. Now what I'll do is I'll divide this a on both sides. So that gives me, and remember, division is just the same thing as multiplying by 1 over that. So this is really the same thing as multiplying 1 over a. So these cancel. So I get what I want to isolate, x plus b over 2a squared equals, and then here this is going to be negative c over a, just like the distributive property. And then this is going to be b squared over 4a divided by a. But remember, division by a is the same thing as multiplication by the reciprocal of a, so 1 over a. So it's the same thing as b squared over 4a and then times 1 over a. Well, the b squared is going to say b squared. And then the 4a times a is going to be 4a squared. So now what I can do over here is give myself a common denominator. We have an a on the bottom here, and I have an a here, but there's also, it's basically an a squared, so there's two a's and a 4. So if I multiply by 4a on the top and bottom, I can get myself a common denominator. So this will become negative 4ac over 4a squared. Remember, what I did is just multiply by 4a on the top and bottom, and then plus b squared over 4a squared. And then what I can do one more time is just combine these denominators. So make this, I could make it negative 4a plus b squared all over 4a squared, but I'm just going to rearrange the terms as well. So I'll rewrite it as b squared minus 4ac over 4a squared. And this is all equal to x plus b over 2a quantity squared. Now what I'm going to do to cancel out this square is to take the square root of both sides, both positive and negative. Now really you only need to take positive and negative square root of one of the sides, but I just like writing it in for both because it helps me remember. So now this side cancels, so all I have left is x plus b over 2a. And then this side, well, this is the same thing as taking the square root of the top and bottom. I'm going to move this down a bit. So now I'm going to rewrite this as plus or minus the square root of b squared minus 4ac over the square root of 4a squared. But the square root of 4a squared, well, 4a squared is technically a perfect square because 4 is a perfect square. A squared is something that's being squared. So I can rewrite this again as plus or minus square root b squared minus 4ac all over 2a. That equals x plus b over 2a. Now, all I have to do to solve for x is just get rid of this plus b over 2a, which is just minus b over 2a on both sides. But what I see here is I have a common denominator. So I can just put this under one denominator and rewrite this as negative b plus or minus the square root of b squared minus 4ac all over our common denominator, which is 2a. And this right here is the quadratic formula. You might see it with the x written on the other side, but this doesn't matter. This will give us our solutions to any quadratic formula in standard form where a is the coefficient of x squared, b is the coefficient of the x term, and c is the constant.